Hello, am I audible and is my screen visible? Someone please let me know.
Yes, sir.
Yes,
Thank you. So welcome everyone to this NPTEL live session for the course Introduction to Machine Learning. My name is Awan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my 10th live session and we will solve some practice questions on week 10 topics, and in week 10 clustering algorithms were covered. So we will discuss some questions on different clustering algorithms and solve some questions on these topics. And if you have any other questions or doubts regarding these topics, you can ask me during this session. So we will start solving the practice problems first, and after that, if you have any questions, you can ask me. Saurav Sehgal, you have raised your hand. Do you have any question or query?
No, sir, I have no question, but I only hands to good evening, sir.
Okay. Yeah. So we will start solving the practice problems first. After that, if you have any questions or queries, you can ask me. This is the first question. Suppose you have a single cluster of data points. The data points are minus 2 comma 2, minus 1 comma minus 2, 2 comma 1, 1 comma 2. These are the four data points in a single cluster. So find the data point x which has the highest average L2 distance with respect to the other points. So among these four data points that are given, which data point has the highest average L2 distance with respect to the other data points? Four options are given, and you can write your answer in the chat. Saurabh Sehgal says option A. Okay. Anyone else? Muthukumaran Iyer says option A. Okay. So in this question, first thing is that you need to know the definition of L2 distance. So that is L2 distance is basically the Euclidean distance. So if you are given two data points x1, y1 and x2, y2, so the L2 distance between these 2 points is defined as x1 minus x2 square plus y1 minus y2 square. This is same as the Euclidean distance between any two data points. So now if we name these four data points given as A, B, C, D, so for point A you have to find out the distance between A and B, A and C and A and D. So you have to find out these three distance for point A and take the average of that. That gives you the average L2 distance from point A to all the other points. Then similarly you have to uh, compute the all the distances from point B also. So point B to A, B to C and B to D, and then take the average of these three distances. You have to repeat this process for the other 2 points also, C and D. Then the question is that then out of these 4 points, which point has the highest average L2 distance with respect to the other data points? So you have to uh, so for the first point, you will compute these three data points. So if this is A, this is B, this is C, this is D. So from point A, you will find the distance between B, C, D. So for the first point A, the distance between point A and point B is 1. Then the distance between point A and C would be, so it's minus 2 square, 4 square. So it would be root over 4 square plus 3 square, which is 5. So I think it should be 5. And then distance between A and D would be minus 3 square, so it would be root over 3 square plus 4 square, it would also be 5. So these are the distances from point A to point B, C and D respectively, 155, and the average of these three would be 1 plus 5 divided by 3. So that is the average L2 distance from point A to all the other distances. Then you have to do the same process for B, then for C, then for D. And if you calculate all these distances, you will find that the correct answer would be minus 2 comma minus 2, which is point A. So point A has the highest average L2 distance um, with respect to all the other data points among these 4 points. Is there any doubt in this question? Okay, then moving on to question 2. Which of the following statements is or are not true about k-means clustering? So multiple options may be correct. You have to find out false statements, not true, about k-means clustering. So first option says that it is an unsupervised learning algorithm. Second option is overlapping of clusters is allowed in k-means clustering. Option C says that it is a hard clustering technique. Option D says that k is a hyperparameter. So you have to find out which of the following statements is or are not true. Muthukumaran Iyer says option C and D. C is hard clustering and D is K is a hyperparameter. Okay. Sweta Lakshmi says option C. Okay. Any other options? So we will go through each of these options one by one and see which of these um, is not true. So first option says that it is an unsupervised learning algorithm. So this is true about k-means clustering. Then k-means clustering is an unsupervised learning algorithm because you don't need the target variables or the decision variables for k-means to work. So this is an unsupervised learning algorithm. This is true. Option B says that overlapping of clusters is allowed in k-means clustering. So that is not true. Each clusters are distinct. So if these points represent one cluster and these points represent another cluster, so these clusters cannot overlap like this. Clusters are non-overlapping in nature. So each data point belongs to only one cluster. So option B is not true, that overlapping of clusters is allowed in k-means clustering. Option C says that it is a hard clustering technique. That is true. So hard clustering basically means that each data point belongs to only one cluster. That means that overlapping of clusters is not allowed. And soft clustering means one data point can belong to multiple clusters with some it's called participation coefficient for each of the clusters. So that is not allowed in k-means clustering. One point can belong to only one cluster. That is called hard clustering, and that happens in k-means clustering. So that is true for k-means clustering. And the final option is k is a hyperparameter. This is also true, that k is a hyperparameter. You have to change the value of k or decide the value of k before you start training the algorithm. So this is not really parameter of the learning algorithm because you cannot change it during the training process. You have to set it before you start the training process of k-means clustering. So option D is also correct. So the only false option is overlapping of clusters is not allowed in k-means clustering. Option B. So this is the correct answer. Option B is the correct answer.
Sir,
Yes.
what is example of soft clustering technique?
Soft clustering k-means can be converted into a version called soft k-means clustering. I don't exactly remember any specific name for soft clustering algorithm for now, but there are many algorithms that allow each data point to belong to different classes with some coefficient, that for with 50% probability it belongs to class A, with 30% to class B, with the other 20% to class C, like that. So
So one more doubt actually. Suppose the distance to two clusters is the same. How
hmm,
to which cluster will the point belong?
then you can choose any one of those two clusters. In k-means clustering, you have to randomly assign that point to one cluster in that case if the distances are same. Because you cannot choose if the distances are all same, you can assign it to any random, any cluster for which the distances are same. Now question 3. Which among the following is or are some of the assumptions made by the k-means clustering algorithm assuming Euclidean distance measure? So there are four options. Clusters are spherical in nature. Clusters are of similar sizes. Data points in one cluster are well separated from the data points of the other clusters. There is no wide variation in density among the data points. So which among the following is or are some of the assumptions made by k-means clustering? Again, multiple options may be correct here. Muthukumaran Iyer says option C. That is, data points in one cluster are well separated from the other clusters. Okay.
What is meant by variation in density?
Density of the point. So this is a highly dense region. This region is not that dense. So the DB scan algorithm was taught in this week's lecture something. DB scan is a density based clustering algorithm which takes into account the density of the data points in a given region. So the Lakshmi says A, B, C, D. Okay.
So can
Chinmay,
you please explain the meaning of fourth option?
explain the meaning of
Fourth option, option D.
option D. Yeah, where I just mentioned that density of the data points. So these are the data points. This is highly dense, and these data points are not that dense. So how dense the data points are distributed in a given region. If there are many data points in a small region, then the density is high. Otherwise, the density is low. Chinmay Chogankar says option C. Saurabh Sehgal says option C. Okay. So the correct answers are option A and B. So the main assumptions made by K-means is that clusters are spherical in nature, or basically round in nature. In three-dimensional space, in two-dimensional it is just like a circle, and in three-dimensional space it would look like sphericals, spheres, and in high-dimensional space it will become hyperspheres. So it assumes that clusters should be spherical in nature because we are using the Euclidean distance method. So clusters should always look like this in K-means clustering. And the other assumption is that clusters are of same sizes. So uh, if we have only two clusters, so if these are the data points and these are the other set of data points. So K-means clustering would divide this region into two equal halves. So both the clusters would have similar sizes. If you have three such clusters, for example, these are uh, some other set of points. So there are three clusters now. In that case, it would divide the whole region or the 2D plane into three equal halves. This is the first region, this is the second region, this is the third region. So it assumes that the clusters should be of similar sizes and divides the whole Euclidean space or the 2D space into equal parts. So that is another assumption made
Actually,
by
yeah, but
different.
option C also, because we are not having overlapping clusters, no? The C also
No,
should be
well
valid, no?
separated. No, the data points might look like this. That this is one set of data points, and this might be another set of data points. They are not overlapping, but might be very close. And K-means would still be able to differentiate between these two classes.
No, but they are still well separated.
Not
Well separated means
well separated means
nothing is
there should be
overlapping.
a no well separated basically means there should be a buffer region between these two, but there might
No,
not be any buffer region. Points
no,
might
no.
be very close to each other.
See, when overlap comes, no, that separation will be not well.
No, the question is that is there any defined buffer region between these 2 points that it assumes? It does not assume any separation between
No, but they
the
are
two
not
clusters.
speaking about any margin here. They are only saying separated. That means A and B,
No,
the
it
points
says
not overlap.
well separated. It says well separated. If you interpret it as differently, then it is on your own. But well separated basically means it assumes a specific threshold distance between two clusters, which is not the case. It does not assume that two clusters might be has to be separated by, let's say, 1 centimeter or something like that. It does not assume anything like that. Points can be very close to each other. Obviously, points cannot overlap with each other. When points can overlap, it will not be able to find out that the clusters are overlapping. It will always find this separation boundary for the cluster, even if the cluster points are overlapping. But it does not assume that the two clusters have to have a specific buffer region between these two. It does not assume anything like that.
Yeah, that is the question, no? So it is assuming that it is so actually my doubt is, suppose the picture you have drawn below, it
Hmm.
shows two classes. One is suppose both are equally spherically, it's very perfectly spherical also, and there
Hmm.
is a very small distance. Then also k-means should be able to perfectly
Yeah,
separate.
yeah. If the data points are spherical, I mean the clusters are spherical in nature in real, then a very small distance between these two, it would certainly be able to find out. But if their points are overlapping, it would certainly not be able to find out. Then you need those soft clustering algorithms if you
That is
want to
why
find
I
out the
thought
overlapping
C
points.
also.
Hmm?
That's why I was thinking C may be correct only because separated only they're telling. Separated with
Now, well
margin they are not.
separated means that whether it is assuming a specific distance between the two clusters, that the clusters have to be separated by 1 centimeter or 1 meter, whatever the threshold it takes. But it does not assume anything like that. It simply computes the Euclidean distance between the centroid and each of the data points, and assigns each point to its closest centroid. It does not assume that the two clusters have to be separated by some margin. It does not assume anything like that in the algorithm.
Okay, and how about option D? Actually, if there is only points of one class, then whether it will work this clustering? I mean,
No,
there is very few
it does
points of
not
another.
take into account density of data points at all. It does not bother about the density of the data points. It is only bothered about the Euclidean distance from the centroid to each of the points. That's why
No, but
you
suppose there are
have the
100
density.
examples. Suppose there are 100 examples of one class and two examples of the other class, then it will not work correctly, no?
100 examples of one class and two examples in other class. Yeah,
Yeah.
if no, if they are separate, if they are distinct, then it can find out. If these 2 points are here, then it cannot find out obviously.
No. Actually, the density only it is selling. So the 100 will be more dense than the two.
Yeah,
Suppose on the so actually suppose the 100 points will be together more dense than the 2 points, no?
so density. Let me explain. Have you gone through the density-based clustering algorithm that is taught in this week's lectures?
Actually, this time I couldn't finish the lectures.
Yeah.
I
So the
yet to.
density of data points. So for example, let's say this. Uh, this is one set of data points that look like this. There is another set of data points that look like this. So the density of the points in this region is high, sorry, and density of the points in this region is high, but in this middle region density is almost zero, or uh, there is no data point in between. So the density based clustering algorithms will be able to find out these two awkward shaped clusters. These are not spherical in nature. These look like bananas or something. So those algorithms work with the density of the data points,
Okay,
that
okay,
in
okay,
which region
okay,
points are densely packed, in which region points are
okay,
not densely packed. So
okay, sir.
based on density, it will find out the clusters. But if
Okay,
you apply k means, it would simply divide the region into two halves like this, some with some straight line, because it only works with Euclidean distance measure. So it will
okay, sir.
simply divide the region into two clusters. It will not be able to find out the exact shape of the clusters.
Okay, okay, okay.
Yeah, if you go through the DB scan algorithm, the which is the density based clustering algorithm taught in the video lectures, you'll be able to understand what I mean by density here.
Okay, sir.
Sir,
Yes,
this regarding third question only, we are assuming that we are using Euclidean distance measure, right?
yes,
And you said that if we are as we are using the Euclidean distance measure, the clusters will be spherical in shape
mm,
approximately.
Mm.
right? So if
Mm.
we use another distance, then will
Yeah,
the
then
shape will be
the
spherical?
shapes might be different. Like if you use Manhattan distance or some other distance measure, then the cluster shapes might not be exactly the same. Yeah, in
So for
Euclidean
Euclidean
distance,
only,
hmm,
for Euclidean distance only, the clusters will be
clusters
spherical
are
in
of
nature.
spherical nature, and generally you use Euclidean distance in K-means clustering. Other measures can be used, but those measures are not very popular, like Manhattan distance, and there are some other distance measures which are not that much popular. But if you use different distance measure, the cluster shape should be different, because the Euclidean distance measure is like this: Euclidean distance between the two data points. So this is very similar to the equation of a circle, or in case of three dimension it will be similar to equation of a sphere. But if you use
Okay.
Manhattan distance, which is like this,
Hmm.
not, you are not squaring the two parts, just modulus of the difference of the two components x and y. So this does not look like an equation of a circle or even a sphere in three dimensional. So some different kind of shape should be formed for the
Okay.
clusters.
Okay, sir. Thank you.
Now question 4: considering single link and complete link hierarchical clustering, is it possible for a point to be closer to the points in other clusters than to the points in its own cluster? So if so, in which approach will this tend to be observed? Option A is no, that the points cannot be closer to the other clusters than to the points in its own cluster. Option B is yes in single link clustering. Option C is yes in complete link clustering. Option D is yes, both single link and complete link clustering. Himanshu Anand is asking, in exam only MCQ will come or code will also come? That I don't know. The final exam question papers are um, created by the instructors, so only they will be able to tell you. You can ask in the discussion forum, there the instructor or the regular TAs will be able to answer your queries regarding the exam. So here the correct answer is it can happen, and in both single link and complete link clustering it can happen. So the question was that is it possible for a point to be closer to the points in other clusters than to the points in its own cluster? So in single link, you can think of two parallel chains like this. This is one chain, this is another chain. Let me put it in different color like this. So the single link clustering would find out two different clusters. Uh, this would be one cluster, and this would be another cluster. Single link would be able to find out these two clusters, and we can see that for this data point, it is much closer than to this red data point than to this point. Although this point is in the same cluster as this blue point, but the distance between these two are much higher than the distance between these 2 points. So in single link, in some cases it can happen. It does not happen in all the cases, but in some of the cases it can happen. For example, this two parallel chains. So point from one chain might be closer to the to a point to in the other chain than in its own cluster. So it can happen in single link clustering, and also in complete link clustering it happens quite frequently, because in complete link clustering we merge two clusters uh, using the complete link distance, and the complete link distance measure is that the furthest distance between the two clusters. If there are two clusters, complete link distance is the distance between this point and this point. This is the complete link distance, and single link distance is just the closest distance in the between these two clusters. So as in complete link clustering, we mark the distances using this complete link distance. It happens quite often that a point in one cluster is closer to the points in the other clusters than in its own cluster. So it can happen in both these hierarchical clustering algorithms. So option D is the correct answer. Now question 5. So I hope this figure is visible in the screen. So consider the following image showing data points belonging to three different clusters. So if the colors are not visible, this is one cluster, this is another cluster, and this is another cluster. So these are the three clusters. So the clusters are shaped as spirals. This is one cluster, and then this is another cluster, and then this one is the third cluster. So which of the following clustering algorithms will perform well in accurately clustering the given data? There are four clustering algorithms given: K means, single link hierarchical, complete link hierarchical, and DB scan. Multiple options may be correct in this question. So single link and complete link hierarchical these single link and complete link clustering algorithms are called hierarchical clustering algorithms. So each data point initially each data point would be in its own cluster. If there are all these data points, each data point will be in its own cluster. Then we start merging the clusters. That's why it's called hierarchical agglomerative clustering algorithms. We merge clusters based on their distance. We merge the two closest clusters, and this distance measure is different in the single link and complete link hierarchical clustering. So in single link, the distance between two clusters, whether two clusters should be merged, this is cluster 1, this is cluster 2, it already has some points in it. So the distance in single link hierarchical clustering is the distance between the closest 2 points. So this would be the distance between these two clusters in single link. In complete link, it is the distance between the two farthest points of this cluster. So this would be this red line would be the distance between the two clusters in complete link hierarchical clustering. So these are the distance measured used, and then the two closest clusters would be merged. So if we merge these two clusters C1, C2, it forms one uh, single cluster in that case. So this way we keep on merging clusters until we have merged all the clusters, or we have reached the intended number of clusters. So that is the brief working, but if you don't understand it completely, then you have to go through the video lectures again. There, these algorithms are explained in detail. So the correct answer in this question would be B and D. That is single link hierarchical clustering and DB scan. So if we go through each of the options one by one, first is k-means. So these clusters, so you can see that this is one cluster. So the shape of this cluster is not spherical in nature. So it will not be able to find out this shape using k-means. So k-means cannot cluster find out these clusters. Then the second option is single link hierarchical. So single link hierarchical would be able to find out because each data point initially would be in its own cluster. So if there are n points, it would start with n distinct clusters. Then it would start merging the closest clusters like this. Then it would merge the bigger clusters like this. Finally, it would merge this whole spiral, and it would form one cluster. So single link would be able to find out this these clusters, but so the option B, single link hierarchical, can do that. Option C, complete link hierarchical, will not be able to do that because let's say at some point we have this cluster, because these complete link and single link hierarchical clusterings work by merging the closest clusters. So let's say this is one cluster at some point, this is another cluster C2 at some point. Similarly, this would also be one cluster C3. So ideally we want C1 and C2 to be merged because these two clusters actually should belong to one cluster. But the distance measure is such in complete link clustering, C1 and C3 would be merged, which is not really intended, and it would completely disrupt the clustering structure in this data set. C1 and C3 would be merged instead of merging C1 and C2. So it will not be able to find out this spiral cluster shapes. So complete link would not be able to find out these clusters properly because of its complete link distance measure. That you need to understand that the distance the definition of single link distance measure and the definition of complete link hierarchical complete link distance measure. Because of its distance measure, it will not be able to merge C1 and C2. It would simply merge C1 and C3, which is not really intended, but it would merge these two. So it will not be able to find out the distinct clusters. Then the fourth option is DB scan. It is a very well known density based clustering algorithm, and the points are uh, distributed in such a way. This is one dense region. Now this is another dense region, and this one is another dense region. So there are three dense regions. Each dense region should actually form one cluster. So this would be C1, this would be C2, this would be C3. Three different uh, dense regions would form three different clusters, and DB-scan being a density-based clustering algorithm, it would be able to find out these three clusters easily. So DB-scan can also find out the clusters accurately. So the single link and DB-scan are the two algorithms that will be able to find out the clusters accurately. Is there any question or doubt here?
No, sir.
Okay. Moving on to question 6. Suppose while performing DB scan, we randomly choose a point which has less than mean points number of points in its neighborhood. Which among the following is true for such a point? Option A is it is treated as noise and not considered further in the algorithm. Option B says it becomes part of its own cluster. Option C says that depending upon other points, it may later turn out to be a core point. Option D, depending upon other points, it may be density connected to other points. The correct answer here is option D, that depending upon other points, it may be density connected to other points. So in DB scan, um, there are three types of points. One is core point. So one is core point. Core points are those points which have more than this mean points number of points in its neighborhood. So neighborhood is also defined as some distance of epsilon. So within this epsilon distance, mean points number of points are present, then That point is called a core point. Another is called boundary point or this density connected point. So those boundary points don't have mean points number of points in its neighborhood, uh, but it has at least one core point in its neighborhood. And the third type of points is called noise points. So these points don't have mean points number of points in its neighborhood, less than mean points number of points in its neighborhood, and there is no core point in its neighborhood. So based on these definitions of these three types of points, option D is the correct answer, that even though that given point has less than mean points number of points in its neighborhood, if there is a core point, it might turn out to be a density connected point or a boundary point later on. But we cannot directly say that it is a noise point, which is given in option A, because if there is at least one core point in its neighborhood, then it would become a boundary point or density connected point. In question 7, which of the following can act as possible termination conditions in k-means clustering? Option A, for a fixed number of iterations. Option B, assignment of observations to clusters does not change between iterations, except for the case of bad local minima, which you don't have to consider. Option C says that centroids do not change between successive iterations. Multiple options may be correct. Chinmay Choga versus option C. Okay. So multiple options may be correct in this question. Basavaraj Hirematsu's A and C. Okay. So the correct answers are A, B, C, all three options. So you might want to terminate k-means after a fixed number of iterations. That is also fine if you are certain that after that many iterations it would certainly converge. The clusters would certainly converge. If you are certain about that, then you can terminate k-means clustering algorithm after a fixed number of iterations. And option B says that assignment of observations to clusters does not change between iterations. It is also fine that if the cluster assignments for each of the points do not change uh, after certain number of iterations, then you don't need to continue anymore. The clusters have converged. It might also happen that it has landed onto a local minimum point, but at that point you can stop. And option C says that clusters do not change between successive iterations. So that is also one of the possible termination conditions, that if the cluster centroids do not change after a certain point of time, then you can terminate the Cummins clustering algorithm, and the clusters have already converged if centroids do not change. So all three options are correct here.
Sir, how
Yes.
we'll come to know that the assignment of observations to clusters is not getting changed per iteration? What
No,
is
you
the
have to
procedure to know that?
track the cluster assignment for every point, isn't it? So you have n
Okay,
data points. For every data point, you have to track which cluster it belongs to. You have to keep track of that during the algorithm. So
okay. Is there
the
any standard function for it?
no, not standard function. Simply there are n points. So the in which cluster does this point 0 belong to? In which cluster does this point 1 belong to? You will simply maintain a list
Okay,
that which cluster this point belongs to. You have to maintain, otherwise you will not be able to find out the centroids. Centroids are basically average of all the data points belonging to that cluster. So to
hmm,
find out which class the all the points inside a cluster, you have to maintain in which cluster a certain point belongs to. So you have to keep track of that.
okay, okay, sir.
Now question 8. So this is a similarity matrix between 6 data points, P1, P2, P3, P4, P5, P6. So this is similarity matrix, not the distance matrix, but the similarity matrix. So difference between distance matrix and similarity matrix is that in case of distance matrix, you would merge two clusters uh, with the least distance value, but in case of similarity, it is exactly the opposite, because similarity is inverse of distance. So you would merge two clusters with the highest similarity. So a similar question is also given in the assignment, but I think that contains, if I'm not wrong, that contains distance matrix of these points, 6.5 or 6 points. Here it contains similarity matrix. So you would merge two clusters in case of hierarchical clustering algorithms with the highest similarity value. So which of the following shows the hierarchy of clusters created by single link clustering algorithm. So you have to use single link clustering to cluster these 6 points. Basavaraj Hiramat says option B. Okay. So this question would be slightly lengthy to solve, and it is also slightly more time consuming than the other questions. So I will show you the steps to solve this. So you have to use single link clustering algorithm, and these are the similarity values given in this similarity matrix. So at every step of this algorithm, so initially each of these data points P1, P2, P3, P4, P5, P6 belong to in its own cluster. So there will be 6 clusters initially. Then at every step you merge uh, two most similar clusters. So initially you have 6 clusters. Now from this matrix you have to find out which pair of points has the highest similarity. So these diagonal points you have to ignore because P1, the similarity between P1 and P1 would always be 1. Similarity between P2 and P2 would always be 1. So these diagonal elements you have to ignore. This is also same in case of distance matrix, that you don't have to consider the diagonal elements. If you consider diagonal elements, you will not be able to solve that. So apart from these diagonal elements, the highest similarity value I can find is this, I think 0.8105. That is the highest value I can find out from this matrix. So this similarity is between P5 and P6. So initially P5 and P6 would be merged. So P5 and P6 would be merged.
0.8421 is also there.
81.
8421, that is between P4 and P3.
P4. Oh, okay, yes. Yeah. Yes, so I was wrong. This 0.8421 point between P3 and P4 is the highest similarity value that you can find out. So first P3 and sorry P3 and P4 would be merged. So it forms one cluster containing P3 and P4. Now in the second step, again you try to find out the second highest similarity value from this uh, table, and now I think this 0.8105, this value has the highest similarity. So and that 8105 is between P5 and P6. So in the next step, P5 and P6 would be merged, so it would be slightly higher. P5 and P6 would be merged, and in the third iteration, again find out the highest similarity among the rest of the values. So after 0.8105, the third highest is probably this one, 0.7895, and that is between P1 and P2. So now P1 and P2 would be merged. P1 and P2 would be merged. After that, the fourth highest similarity value would be fourth highest, I think, is this one. No, sorry, not this one. This one is the fourth highest.
0.70.
Okay, 0.70 is there. 0.7. Where is it? Oh, yeah, here.
0.7023.
Yes. This has the highest, fourth highest similarity, 7023. So that is between P5 and P2. So P5 is already part of this cluster P5 P6, and P2 is already part of this cluster P1 and P2. So we will not just merge P2 and P5 because they have the highest similarity from the remaining table. We will merge these two clusters. P5 P6 will be merged with P1 P2. So now this whole cluster, this bigger cluster would contain P5 P6 P1 P2. The other cluster now contains P3 and P4, and finally there are only two clusters remaining. So in the last stage, obviously these two clusters should also be merged. So finally this would be the structure. So first P3 and P4 are merged, then P5 and P6 are merged, then P1 and P2 are merged. Then here, then these two clusters P5 P6 and P1 P2 are merged to form a cluster of 4 points. Finally, the two clusters are merged here. And if we check the options, it is same as option B. So P3, P4 merged first, P5, P6 are merged second, then P1 and P2. Finally, this P5, P6, P1, P2 are merged. Finally, the two remaining clusters are merged at the highest level. So option B is the correct answer. So this is how you can compute the hierarchy of clusters and also the clusters in the single link clustering algorithm. So is it understandable?
Yes, sir.
Yes, sir.
So if you have distance matrix, then the uh, process would be exactly the opposite, that instead of finding the uh, pair of points with the highest similarity, you would find the pair of points with the least distance. You would merge those 2 points. So option B is the correct answer. Now question 9.
And difference between single link and multi-link?
Single link and complete link it's called.
If same, yeah, if same question is asked for complete link.
In complete link, the process would not be that easy, because complete link distance basically means distance between the two farthest points of the two clusters. For example, while merging single data points are easier, even in this case it would be similar to like just merging P3, P4, then possibly P5, P6, something like that. So at some point, if you have, let's say, if you have these two clusters, P5, P6 is one cluster and P1 and P2 is the other cluster. So whether you would merge these two clusters like this or not, for that you have to find out the distance between the two farthest points in these two clusters. So you have to find out the distance between P5 and P1, P2, then P6 to P1, P6 to P2. Then find out which is the highest among them. Because complete link basically means distance between the two farthest points in the cluster. If this is one cluster, this is another cluster. So the complete link distance is this distance between the two farthest points in these two clusters. Single link was much easier, simply the two closest distance between the two closest points of these two clusters. That's why in single link clustering, in every iteration you find the highest similarity value remaining in that table. But in complete link, it would be much more difficult to find out, and it would also be uh, much more time consuming. Now question 9. In which of the following cases will k-means clustering fail to give good results? Data points with outliers, data points with different densities, data points with round shapes, data points with non-convex shapes. Multiple options may be correct in this question. Basavaraj says option A, Subarna Bhagwat says option A. Okay. So the correct answers are A, B, D. Three options are correct here. So option A says that data points with outliers. If there are outliers, K-means should not be able to detect whether a given point is an outlier or not. It would treat all the points similarly, and outliers can hamper the cluster structure in K-means clustering algorithm. So if you have outliers in the data set, then it would not be able to give a good result. And data points with different densities, as we discussed that density based clustering algorithms are different, and it does not take into account density of data points. It simply computes the Euclidean distance. That's why it only is able to compute spherical clusters. Option C says that data points with round shapes, obviously it would be able to give good results if the data points or the clusters have round shapes only. And option D says that data points with non-convex shapes, if the data points have non-convex shapes like the spiral structure that we saw initially previously, So if these are the two clusters, K-means clustering would not be able to find out those shapes or clusters. Also similarly, if this is one cluster and there is another concentric cluster like this should, yeah, if this is, sorry, the uh, the red one is one cluster and the green one is another cluster. uh, K-means clustering would not be able to do that because these clusters are concentric in nature. It would not be able to distinguish between these two clusters, but density based clustering algorithms and hierarchical clustering algorithms would be able to find out these clusters. So A, B, D, these are the three correct answers. Now question 10. Consider the following 3 points in a cluster: 2, 1, 3, 4, 5, 7. So all these, each of these 3 points belong to a single cluster. Now compute Barch cluster feature for this cluster. So this cluster contains 3 data points: 2, 1, 3, 4, 5, 7. So you have to compute the Barch cluster features for this cluster. Shweta Lakshmi says option D. Oh no, that is for the previous question. Basavaraj says option C. 3, 6, 6, 125. Okay. So Barch cluster features for a given cluster C contains 3 components. First one is the number of data points in that cluster C. Second one is simply the vector sum of all the points belonging to cluster C. And third one is uh, the squared sum of all those points in that cluster. So NC, which is the number of points in that cluster, there are 3 points in this cluster, so this first component would be 3. Second component is vector sum of the all the points belonging to that class. So vector sum, so there 2, 1, 3, 4, 5, 7. These are the 3 points. So vector sum would simply be component wise sum. So x component of the sum would be 10 and y component of the sum would be 12. So vector sum of the 3 points 10, 12. Third one is the squared sum. Squared sum basically means 2 square plus 1 square plus 3 square plus 4 square for the second point. For the third point is 5 square plus 7 square. So this is for the first point, this is for the second point, this is for the third point. And if you square these three, it would be, I think, 104. So there will be 104. So this is the correct answer: 3, 10, 12, 104. So this is how you compute Barch cluster features for a given cluster. So option D is the correct answer. So these were the questions that I wanted to discuss in this live session. And now if you have any other questions or doubts, you can ask me.
Sir, can you repeat the GB scan and question 1 and question 2?
Question 1 and question 2. Question 1, if you have missed initial part of this live session, you can um, uh, watch this on YouTube later on. So simply the question 1 was that you are given 4 data points in a cluster. Now you have to find out which data point among these 4 has the highest average L2 distance with respect to the other data points. So basically for every point you have to find out the distance from that point to all the other 3 points and then take the average. So for the first point A, you have to find out the distance from A to B, C, D, A to B, A to C, A to D. And distances are 1, 5, 5, so average would be 1 plus 5 plus 5 divided by 3. And you have to compute this for all the other 3 points. And then the point with the highest average L2 distance is the answer. So that is very easy to calculate. Simply you have to know the Euclidean distance formula. And 2 was simply which of the following statements are not true. So the overlapping of clusters is not allowed. Overlapping of clusters is allowed in K-means clustering. This is not true. Overlapping of clusters are actually not allowed. So that is not true about K-means clustering. And DB scan, it would be better if you go through the video lecture second because it is quite a long algorithm, a lengthy algorithm. So basically in DB scan, in every iteration you go to one point and try to categorize that point into 3 categories, whether it is a core point. If the point has mean points number of points in its epsilon neighborhood, then it is a core point. If it does not have mean points number of points, but there is at least one core point in its neighborhood, then it's called a boundary point. And if the point does not have more than mean points number less than if the point has less than mean points number of points in its neighborhood and there is no core point in its neighborhood, it is called a noise point. Uh, in this way, you try to categorize each point, whether that point is a core point, boundary point, or density, noise point. And this process is recursively done for the neighborhood of that point also. So the whole algorithm is quite lengthy. So it would be better if you watch the video lectures again. There, it is explained in much more detail and in a much better way.
Okay, thank you, sir.
Thank you, sir.
Thank you. If there are no other questions or queries, we can end this live session now. Thank you everyone for joining. We will meet again next week.